back to the quiet. Welcome, Hunter, to this day. It is this 2016. I'm not used to writing it, are you? January the 4th. So this is Monday, our first day back from our break, and we have the task of getting back on task and remembering what we were studying. It was one of those mods that ended right before Christmas break, right in the middle of the mod. There's nothing you can do about that. So what I'm going to spend the day doing is bringing back to mind the different things that we learned in this mod. The thing that holds these problems together is Newton's second law, which is in the mathematical equation, looks like this. The sum of what? Brian, do you recall the second law in math?
Just math.
Pardon?
Just math.
Yeah, I mean, what is the equation, the mathematical equation for the second law?
Sum of all forces in an
Equal.
object is equal to its mass
Yeah,
multiplied by its area.
exactly. Sum of the forces equals ma is the thread that ties all this together. Is that poetic? All right, so let's go from there. We're going to do the first one. Now, what I can do, this is, I don't think I ever gave you a sheet that actually combined, that told you what every day was going to be, this mod. So this should go in the front. Now, I also got to the dollar store and got more dividers. Does anyone need more at this point?
Yes.
Because this is mod 6. So you should be in your notebook behind the divider for mod 6. So divider person, anyone need dividers?
Need these to
Anyone else?
Not for now.
Okay.
Mine's always my favorite food school supplies.
They're not the best quality, but they'll do. So when we were studying tension, tension was on day 1. So that's what I'm reviewing. So I can give you, is there a part, I don't know where you want to put this review problem. I want it in your notebook somewhere. If you want to go back to day 1, I can just give you a piece of paper.
I have
And you can do that, or if you have plenty of room in day 1 already,
Nope.
you can do that. So somehow, this is a day 1 problem. So let's put it there, so we kind of keep our notes organized. Let's review how this works. Here's a typical day 1 problem. So would you sketch it in your, somewhere in your day 1 area, and it's going to serve as our review.
Can I have one?
Yes, you may. Which one?
Just the blank.
The blank. You want a blank?
Thank you.
Blank.
Sounds good.
Alright, so this is, again, day 1. And if you would sketch that, there's 2 wires that are, you need a piece of paper. You don't want to take it on that. That goes in the front of your mod 6 work. And this goes in day 1 somewhere. So you have a wire that is provided at 15 degrees. I called it tension 1. Remember, the force of tension is always away from the object suspended. Tension 2 is 45 degrees on this side, and a 12 kilogram mass is hanging from the 2 wires at like that. And the question typically is find the tension in the wires. So let's, if you can, go ahead and work this out. If not, I'll slowly bring it back to mind. What you want to do with these is you want to do a horizontal side, horizontal forces, and I'll do those in red. I think there's only 2 horizontals. Do you recall that often? There's 2 horizontals and
3 verticals.
So
You got it.
I'm going to put in the blue for my verticals.
Oh, I don't like that chocolate.
So the name of the red ones, which I'm going to work here, has to do with trig, and it's going to be T1 cosine 15 for the name of that one. And it's going to be T2 cosine, but I'm not gonna use 45 because,
Get that.
right, you have to remember this is on a coordinate plane. So we're gonna remember what that angle is. We start measuring our angles from here. So if I stop 45 short of 180, that is 135?
Yeah.
So that's the number for that one. So in red or pink, I put in the horizontals, and so they are going to appear on the board here. So T2 cosine 135 plus T1 cosine 15. So the sum of the forces equals
No.
MA, but our acceleration is 0 because the objects are still. So the sum of the forces are listed there. MA is 0. So I've written that like that. All right, you can take that only to a certain point. Without me, can you find the cosine of 135? Make sure you are in degrees. Can you find the cosine of 15? And there's not much further you can go. I'm not going to put every step. I solved for T1 and I moved T2 to the other side. Here's what I got on my last step. I didn't show you everything in between. Can anyone confirm that when they get to the bottom of this side? The cosine of 135 must be a negative 0.7. And I moved it to the other side. I probably used 3 decimals, look like. At the end I won't, but in the middle I did. Looks like the cosine of 15 was 0.966. So I moved this to the other side and divided by the coefficient of that. Anyone get that?
Before we go on break, hold on.
What'd you solve for T1?
Wait.
Did anyone get that? Anyone?
I got negative.
Yeah, I
Well,
got
this
negative
should have
1.
been negative.
Do you
This one should
one?
have
Oh, yeah,
been negative,
it's-
so when
yeah,
you
I
went
got that as-
over, it
yeah.
became positive.
Okay, yeah.
But you
That's
didn't
what
get
I got.
0.732?
Mhm.
Oh, you did. All right, it's
Yeah.
been confirmed.
Yep.
So, at this time, there's no further information I can get from the horizontal forces, so I have to switch to the verticals. There are 3 of them, so I'll put in their names. This one is T1 cosine 15, I'm sorry, sine, verticals are sine. And this one's T2 sine, remember we're using 135. And all I need is the weight. So our weight equals mg. So 12, I'll do that work right here. Weight equals mg. M is 12. G is 9.8. 12 times 9.8 came out to 117.6. Which I used all those decimals. I was in a decimal mood. Vertical. Alright, so vertical or vertical? I forget. Alright, so
Vertical?
I can't remember how to spell vertical.
Oh, I was like, you call it vertical?
No.
I was like, what? I was like,
Spell
what is
L-E or A-L. It's better this way. Alright, so T1 sine 15. I grab this one plus T2 sine 135 minus, I know the weight is downward, 117.6 equals 0. Sorry, my board space is limited. So, what I do now is calculate the sine of 15, calculate the sine of 135, and then I replace the T1 with 0.72 T2. So I'm going to put that in for that. I can show you that work just in case you're rusty. I will put it down here. So all of this work from this column is down here. I got T1 with a 0.259. T2 was 0.707. And I moved the 117.6 to the other side. Now I'm going to make this substitution. Everywhere there's a T1, I'm gonna put in a .732 T2.
I don't get 259. Hey, Miss Powell,
Uh-huh.
where are you getting the point 259?
Was it not
Because it's sign 15. It's a sign of 15.
the sign of, was it the sign of 15? No? Check your degrees.
Yeah. Oh.
Okay, you all right?
Yeah.
All right, so
I
now
was doing it.
this comes out to be .190 T2 plus .707 T2 equals 117.6. These are like terms, they both are T2s, so I'm going to add them together and I get .897 T2 equals 117.6. So now my last step is to divide, and T2 came out to be 131. Anyone confirm?
Yep.
131 newtons. Looks like we're dealing with 2 sig figs, so I will change that to 130. Don't forget sig figs, 130. Now we go back. Where on the board can we go to find T1? Any equation, yeah,
You can go to T1 equals .732
right
T2.
here is grab the easiest spot. So I'm gonna do that. So right here, I know T2 now, so I can replace that with one, I put 131 at that point, I just hadn't used my sig figs to the end. And when I did that, I got 95.16, which equals 95 newtons.
It's the end of the timer.
That's a good
Oh, I
spot.
was like, what the heck? Who's taking that beat? I was like,
Scared
low
me.
key fire. I was like, sorry.
All right.
I'm gonna keep things awake and alive to this morning. So I got 130 and 95.
Alright, there's the answer.
Yeah.
All
There you
right.
go.
We're gonna. Okay.
Almost.
See,
Onward.
see you in like 2 minutes.
Right.